have seen TON 618, the black hole that swallowed 66 billion suns, the abyss so vast that our entire solar system would vanish inside it without touching the edges. We called it one of the largest black holes in the universe. We were wrong. Somewhere in the constellation of Phoenix, billions of light years from everything we know, sits something that makes TON 618 look like a grain of sand. 100 billion solar masses, compressed into a single point of infinite darkness. This is not a record that will be broken easily. This may be the absolute limit of what the universe is physically capable of creating. This is Phoenix A star, and according to everything we know about how black holes form and grow, it should not exist. We live in a universe of extremes. Black holes that anchor galaxies, neutron stars that pack the mass of a sun into an object the size of a city, voids so empty that light takes hundreds of millions of years to cross them. But even in a universe built on extremes, there are anomalies that break the rules entirely. Phoenix A star sits at the center of the Phoenix cluster, a structure containing over 1,000 galaxies, bound together by gravity into one of the most massive objects in the known universe. And at the heart of all of it, a black hole so incomprehensibly large that physicists still argue about whether the numbers can be trusted. TON 618 broke our understanding of scale. Phoenix A star breaks our understanding of limits. Welcome back to the absolute nightmare of astrophysics. In 2010, astronomers conducting a survey with the South Pole telescope detected an unusual signal from a distant galaxy cluster. The object was catalogued and flagged for further study. Its full nature would only become clear years later when data from NASA's Chandra X-ray Observatory revealed what was hiding at its center. Chandra does not see light the way human eyes do. It detects X-rays, the invisible radiation produced when matter is torn apart by extreme gravity and heated to millions of degrees. X-rays are produced when matter is heated to temperatures that make the surface of our sun look cold. What Chandra detected from the Phoenix cluster was a signal so powerful it took years for anyone to believe the numbers. The data showed a cooling flow of gas falling inward at a staggering rate, matter collapsing toward the center of the cluster in enormous quantities. To produce a gravitational pull this powerful, the black hole at the center would have to be consuming matter at close to the theoretical maximum rate. When astronomers modeled the mass of the object responsible, the result came back at approximately 100 billion solar masses. The Phoenix cluster had been hiding the largest known black hole in the observable universe, hiding it in plain sight, and we had only just found it. Let us talk about what 100 billion solar masses actually means, because the human mind is not built for numbers like this. Sagittarius A star sits at the center of our own Milky Way. It weighs 4 million times the mass of our sun. It anchors 200 billion stars. To us, it is unimaginably large. TON 618 weighs 66 billion solar masses. We made an entire video about how wrong that number feels. Phoenix A star is 50% more massive than TON 618. Its event horizon, the boundary beyond which nothing, not even light, can escape, stretches across 590 billion kilometers. That is 100 times the distance from the Sun to Pluto. A beam of light traveling at 300,000 kilometers per second would take over 70 days to cross from one side to the other. This is not an object you fly past. This is a region of space that has ceased to function by normal rules. A place where the geometry of reality itself has been rewritten, and it sits at the center of a cluster of over 1,000 galaxies. each one containing hundreds of billions of stars, all of them, in some sense, orbiting this single point of darkness. But the size is not the most disturbing thing about Phoenix A star. The most disturbing thing is what it does. To understand Phoenix A star, you have to understand the environment it controls. Most galaxy clusters are ancient and quiet. The violence of their early formation faded billions of years ago. Stars stopped forming, gas cooled and settled. The cluster became a graveyard. The Phoenix cluster is different. It is still actively forming new stars at a rate approximately 740 times higher than our own galaxy. The Milky Way produces roughly one new star per year. The Phoenix cluster produces 740. This is not normal. This is a cluster still alive with creation, fueled by an enormous flow of cooling gas collapsing inward toward the center, toward Phoenix A star. And here is where the physics becomes deeply strange. When Phoenix A star enters an active feeding phase, it releases jets of energy from its poles so powerful that they heat the surrounding gas across the entire cluster. This heating suppresses star formation. The gas cannot cool. Matter stops falling inward. Then the jets quieten. The gas cools again. Matter begins to fall. Stars form, and eventually enough material reaches the black hole to trigger another feeding phase. Phoenix A star does not merely exist inside the Phoenix cluster. It regulates it, like a thermostat controlling the temperature of a structure containing 1,000 galaxies. Here is what separates Phoenix A star from every other black hole we know. Most supermassive black holes grow slowly, consuming matter over billions of years, averaging a small fraction of a solar mass per year, patient and invisible. Phoenix A star, in its active phase, consumes approximately 60 solar masses every single year. Our entire sun, 60 times over, every year. This is close to what physicists call the Eddington limit, the theoretical maximum rate at which a black hole can feed before the radiation it produces pushes matter away faster than gravity can pull it in. Phoenix A star feeds at the very edge of what physics permits. And this raises a question that has no comfortable answer. How did it get this big this fast? The universe is only 13.8 billion years old. To reach 100 billion solar masses in that time, Phoenix A star would have had to begin growing almost immediately after the Big Bang, from a seed of extraordinary size, or through mergers so catastrophic they have no parallel in anything we have ever observed. Some physicists have placed Phoenix A star in a proposed category called stupendously large black holes. Objects so massive they may trace their origins back to primordial black holes, seeds of darkness formed in the first moments after the Big Bang, before the first stars, before the first galaxies. If that is true, Phoenix A star is not just the largest black hole we know. It is one of the oldest objects in the universe, a relic of the very first moments of existence that has spent 13 billion years doing nothing but consuming. Right now, Phoenix A star is in a quieter phase. The jets have pulled back, the feeding has slowed. The blinding accretion disk that once made it one of the most energetic objects in the observable universe has dimmed. From the outside, it has become what all black holes eventually become: invisible, patient, waiting. 100 billion solar masses do not disappear. They simply stop announcing themselves. We discovered the Phoenix cluster in 2010. We understood what was hiding at its center only years after that. Before those discoveries, it was invisible to us. 100 billion suns compressed into darkness, billions of light years away, and we simply did not know it was there. And that is the thought that should stay with you long after this video ends. Not the size, not the feeding rate, not the jets tearing through 1,000 galaxies. Look up at the night sky. Every point of light you see is a star. Behind those stars are galaxies. Behind those galaxies are structures so vast they have no name in any human language. And somewhere out there, in the dark between all of it, things like Phoenix A star are waiting, silent, invisible, patient. We found this one 15 years ago by accident. The universe is under no obligation to show us the rest.